Here I want to demonstrate how to bring a Kaggle dataset into Google Colab for analysis. So when I go into my Colab account, I have created a Jupyter Notebook file under Google Drive, which is important to know that when you exit Colab, all of your storage is ephemeral. So if you want to keep things permanently, you need to download it or put it in Google Drive, for example. So I'm going to pull up the code that I wanted to show you today, which is on classifying chess pieces and creating a fen string from the chess pieces that allows you to feed that into a computer program for downstream analysis. The steps to download a Kaggle dataset into Google Colab are documented in this Kaggle note, and I'm going to first set up so that I'm mounting my Google Drive to Google Colab so that I can work with it and store my data on the Google Drive. I'm going to, from Google Colab, import files, and then the files.upload I need to upload kaggle.json. And going over to Kaggle for a minute, this is documented in the Kaggle note that I just referenced. I can go to my accounts, and under API, I can say expire token, create new token, that downloads it to my machine. So when I run this, I already did that. When I run this, files upload prompts me for a file. And this is where I had kaggle.json stored. And now I can install the Kaggle API package. I need to change directory to Kaggle and copy the JSON file over into it. And the Linux command set the security the way it expects to 600 because it's a security requirement of using it. I can see the folder I'm in, which is content, G drive, my drive, data. Just to verify that the API was successful, I can list all the Kaggle datasets. That's the start of many, many. Bring up the Fast API, Vision API. Now I'm going to download this chess pieces dataset, and I'm going to download the path command from Fast Core Extras, which does monkey coding to dynamically add some functionality to Python's path object. And I'm taking this zip file and unzipping it into a data folder underneath. And I can see that I'm in content, G drive, my drive, data. Change directory to that folder. And now under that, there's a downloaded path and a resized path. And I'm going to, in the downloaded path, I'm going to look and see what is there by going to G drive, my drive, to data. And I can see that in the data folder, it's created one folder for each chess piece, and under that, the PNG files. And I did this when I unzipped the zip file. And when I resize the images, and they need to all be the same size in order to be able to put them through the GPU for batch loads in training, it's now in the downloaded path folder, added the same files. The download path folder is chess pieces. So these are the PNGs that have all been resized to the same number of bytes. I can verify if any of the images are bad. Perhaps I should have done that before I resized them. And then I can use a data block, which is a medium level fast API, and it shows me different pieces and the labels for them. The get items gets image files. That means in the given folder, look and grab the, in this case, PNG files. Get Y is going up to the parent from that. I can look at the labels. I can see the mapping of labels to numbers, which can be helpful if I'm playing with different thresholds to tune my probabilities. Now, I'm running 5 epochs using ResNet 34 and an accuracy metric, and it would be 10 or 100 times slower if I didn't have a GPU. I'm spending $10 a month with Google Colab. The free version might use a GPU that takes a little longer to run, might be 7 or 8 seconds, but it'll still be very good per epoch. And I can look at a couple test pieces. So a black king is identified correctly. A white bishop or a bishop is also identified correctly. I can create a confusion matrix and see that things went very well, I believe. I can see where the most confusion was. The first iteration of this, it was really having a lot of trouble with bishops and pawns. I changed the size of the images and went from ResNet 18 to ResNet 34. So we can see where there is more problems here, not very many misses. So things to consider, if the goal is to create a Venn string, what other information might we need? Were there certain chess pieces that got more confused? If we needed to improve our accuracy, how might we do that? And this specific Kaggle dataset, how did it indicate what the label for an image was, and what other ways might you do this with image data? And that's what I got.